My name is Marla Reikman. I'm a soil management specialist with the province of Manitoba. And I've known Jodi for a couple of years, and she and I do a lot of the same type of work. And so she invited me to come down here and speak a little bit on some of what we've been doing, looking at shallow incorporation using vertical tillage on urea. So the reason why Jodi wanted me to come down, anybody broadcasting urea, broadcasting fertilizer, broadcasting peat? Okay. Anybody using shallow vertical tillage, something like that, in order to incorporate? Couple? Okay. This is something that's moving into Manitoba. And the reason why I've got to know Jodi over the last few years is we've been dragging her up to talk to us about vertical tillage for so long that now I've finally learned a little bit. And now I'm getting calls in Saskatchewan and Alberta to have to go west because there's just not a lot of people that know about the equipment. And there's a lot of sales going on, and it's starting to pick up steam in terms of a piece of equipment that people are wanting to use. And people are using it in the zero-till land, people are using it in the heavy clay land, in conventional tillage. It's got quite a wide range of uses. I set up a demo, and the demonstration was we broadcast urea at 100 pounds per acre rate of nitrogen, actual nitrogen. And then we left it either lying on the surface, or we went over it 1 time with a vertical tiller, or 2 times, a 2-pass system. And now the vertical tiller that we were using it had an 8-wave coulter on it and a harrow bar behind. It had no angle on the gang, so while it has a slightly more aggressive wave coulter, because there was no pitch to it or no angle, there wasn't a lot of soil mixing, just a lot of cutting. We also did this in July, and it's on a lighter clay soil, or a lighter textured soil, a bit more of a sandy loam type soil. And we had a fair decent amount of moisture in it, and it turned a lot better than I was expecting it to. So I actually had better incorporation than I expected. But we did that with broadcast urea. We also did the exact same thing where we had broadcast ESN. And the reason why we did ESN is for 2 straight weeks, I have to stand there and talk to farmers and agronomists at this site. And for 2 straight weeks, they could see the granules lying on the surface because of that polymer coating. And so it gave me a bit of a visual. So where we were looking at no incorporation of the ESN, there was around 38 granules per square foot left lying on the surface. Where we ran 1 time with the vertical tiller, a 1-time pass left 7 granules per square foot still on the surface. So that's still left on the surface, ready, exposed for things like volitalization and losses. Where we went 2 times with the vertical tiller, we had 5 granules per square foot still left on the surface. So it still didn't have, even though it looked physically like there was a fair bit of turning of soil on the surface, still wasn't enough to actually incorporate that fertilizer. Now I'm worried about that in terms of the amount of loss that you might have to volatilization, and the loss of nitrogen is a loss of money in your pocket, because if that nitrogen's not there for the crop and it's just gassing off all the time, then you're just putting wasted dollars down. I'm also worried about it because I come from Manitoba. We have a bit of a recreation problem. Lake Winnipeg, has anybody heard of it or traveled to Lake Winnipeg? It's a very large lake. It's quite beautiful, just not at this time of year when it's all green. And the algal blooms are there, and the stuff washes up on this beautiful beach, and it's useless. It's not a pretty sight to behold. And so we have had this issue with phosphorus. And so the reason also, not just from a nitrogen standpoint am I worried about shallow incorporation, but for us, because people might be looking at broadcasting phosphorus and doing a very light and not very incorporated type system, if they're running a very more of a true vertical tiller over top and not really getting a lot of soil fertilizer contact, now we're going to have an issue. One thing that happens for us in Manitoba, and I know in the northern parts here, for us, we don't get quite as much rainfall as you do. For us, 15% of the total runoff that actually reaches the lake is from rainfall, and 85% is from snowmelt. So all of that stuff melts on the surface, and if that phosphorus is left exposed on the surface, if it can wash off, then that's where all of that phosphorus is making it, if we have that high driver. A lot of it's actually coming out of plant residue that's lying on the surface and stuff as well. It's not just from fertilizer, but it is one thing that we have a concern with. And so we are trying to encourage a little bit more, we do a lot of seed place with phosphorus, but we're trying to move away from any impact of banding or of broadcasting in that situation. So back to nitrogen. What we did So visually we could see on the surface that we had a lot of these grains of ESN, the polymer coated urea that stuck around for the 2 weeks. But the other thing we did was we actually measured the amount of volatilization of ammonia that happened using something called a dosatube, or this dosimeter. And what happens with this is it starts off all purple, and as this end draws in ammonia, it actually changes the color. It's kind of like a litmus paper. And so we would take these tubes, and these are tubes that I actually took from the field where we had this little trial. We would take these tubes and we drive a stake into the ground, and you put the tube about 6 inches above the ground, and we just wrap an elastic to hold it in place. We take a blue box, our old recycling boxes, because we've moved to big bins in the city of Winnipeg, so we were stealing old blue boxes from all of our neighbors. And we drilled holes in it to allow some air movement to come through. And we put the box on top, put a rock down to weight it so it doesn't blow away, and sit and wait. Now when it rains, you expect to have another possible flush that comes. So once we would have a rain, the area under the box didn't get wet, so it's not reading the same, it's not reacting the same as the rest of the field. So we pick the box up, put a new tube in place, move it down the line, and keep adding these boxes. So we did this over 2 weeks, and what we found was where we left the urea lying on the surface, we had 400 parts per million of ammonia that were collected in these little dosatubes over the course of about that 2 week period. The first 3 days there was no rain. And if you're putting urea down on the surface, you want to have some rain to actually help move it down in. We had no rain for 3 days. We had 300 parts per million of urea that was actually read off that. That's this tube right here. So I'll pass this around so you guys can take a look at it. Where we had one-time incorporation using the vertical tiller, we still had a flush in that first 3 days where no rain happened, and we were reading about 25 parts per million. There you go. And where we had 2 times, there was no ammonia emissions seen in the first 3 days. Then it rained, and we actually got a ½ inch of rain. So you would think that with a ½ inch of rain, that would now be enough to take that urea, even the stuff that's lying on the surface, and push it down in, because that's more than enough in order to help dissolve and move that urea into the soil. And we still had another 100 parts per million of volatilization that occurred where the urea was lying on the surface. So obviously, even with that amount of rain, there was still a release that happened. Where we had the 2 times, with that rain, we started to see some losses as well. So in the end, we had about 400 parts per million loss where the urea was lying on the surface, and there was 25 parts per million, 25 to 30 between the 2 where we had actually done some kind of incorporation. Not a real difference between the 2, but there's still a loss that was happening. Now there's always going to be background losses that can occur as well, but really when I was able to visually see that much fertilizer still exposed on the surface and knowing how much is still kind of coming out, not exactly the best placement and the best way to actually be conserving your fertilizer in that case for the crop. Vertical tiller was running at about 2 inches. And the vertical tiller, when we were running it, didn't quite get up to speed because it was a smaller area. We borrowed a unit from one of our neighboring farmers, and because it's at a demonstration, like a research farm, we didn't have a full field size area to work with. So we got up to about 7 miles an hour. So not quite as high speed as I would want to see him running. But it came to a screeching halt at the grass runway right at the very end of the field. It was a lot of fun.